Hi folks, continuing here with number 8 on the practice quiz 5. You see that? Practice quiz 5. All right. Number 8. Which of the following samples has the greatest density at STP? Notice STP is here, and these are all gases. These are all different gases. So there is also no change in temperature, no change in volume in this problem. So it's either ideal gas law or Avogadro's law. It could be either one. Avogadro's law is the easiest here because Avogadro's law says that at STP, you can get any gas. If it is at STP and it is behaving as an ideal gas, then 22.4 liters is the volume that 1 mole of that gas would occupy at STP. Notice in this problem, a volume is not given. That means you can pick whatever volume you want, as long as you pick the same volume for each of them. Let me pick 22.4. If I pick 22.4 liters as the volume, then I'm going to have 1 mole of each of these gases. Why am I talking about volume when the problem is asking about density? That is because density means mass over volume. The units for density are grams per liter when you are talking about a gas, grams per milliliter if you are talking about a solid usually. So liters is volume. That's why I'm talking about volume right now. Now, what about the grams? How am I going to get that? Well, if all these gases are at STP, and I have 22.4 liters of each one of these gases, that means I have 1 mole of each one of these gases. Okay. So how many grams is 1 mole of each one of these gases? Well, that's going to be the molar mass, right? Grams per mole. Look on the periodic table. This is going to be 28 grams per mole. This is going to be something much higher. This is going to be... So which one is going to have the greatest density at STP? Well, let's have a look at the periodic table. See, xenon here is 131 grams per mole. I know that carbon dioxide is 44 grams per mole. I know that nitrogen dioxide is maybe 46 grams per mole. And nitrogen is 28 grams per mole. So this one is the heaviest one, grams per mole. The molar mass of xenon is the highest. Okay, now does the fact that the molar mass is the highest for xenon also mean that the density is the highest? Yes, if we're talking about STP, folks, because at STP, 22.4 liters of any gas is 1 mole of the gas. So if I have 22.4 liters of this, 22.4 liters of this, 22.4 liters of this, 22.4 liters of this, that means 1 mole of this, 1 mole of this, 1 mole of this, 1 mole of this. That means I've got for nitrogen, that's 28 grams per mole, so that's 28 grams per 22.4 liters. For nitrogen dioxide, that's 46 grams per mole, so that's 46 grams, that's 1 mole, for 24 liters. For carbon dioxide, that's 44 grams, that's 1 mole, for the 22.4 liters that I am assuming that I have, right? Then for xenon, that's 131 grams per mole, so that's 131 grams for the 22.4 liters. Which of these is the larger number? You do the division on your calculator, and you'll find that the xenon is the largest number. What about number 9? I've got STP again, 1.43 grams per mole at STP. So this is a typo. Let me correct this. This should be grams per liter. 1.43 grams per liter at STP. What is the gas? Okay, let me fix that right now so that nobody gets confused. That should be grams per liter. Okay, that should be, there we go, grams, oops, number 9, yes, grams per liter at STP. What is the gas? To figure out what is the gas, we need to find the grams per mole. You know that this is 28 grams per mole from the periodic table. This is 44 grams per mole. This is 32 grams per mole. Don't worry, Mama's there. This is, what is this? This is 28 plus 16. 28 plus 16 is 44. This is also 44 grams per mole. Wow. So CO2 and N2O are the same. That might end up being a problem. But for now, let's just, let me just save these changes. Save changes. Okay. 28 plus 16 is 44. Wow, so that could be a problem. Let's see if either of those is the answer. Let's see. The density of a gas is 1.43 grams per liter. What is the gas? There might be another typo in here. Okay, anyways, so if it's grams per liter, then what is this? And it's an STP, what is this in terms of grams per mole? Well, let's see. If it is 1.43 grams per liter, and an STP 22.4 liters are 1 mole, then the liters will cancel and I'll get grams per mole. So 1.43 times 22.4 is 32.0. So the answer here is 32.0 grams per mole. That is the molar mass of the oxygen. So there is no further typo. That was the only typo. This was grams per liter, not grams per mole over there, because of course we needed to calculate the grams per mole. Okay? I will verify that the typo does not exist on the quiz after I finish with this video. Okay? A mixture of these gases have these mole fractions. What is the pressure of nitrogen? There is the nitrogen. If the total pressure is 0.95. This is a partial pressures problem. I think I have a Tyler DeWitt video posted for you about partial pressures. It might have been Khan Academy. But either way, it's the pressure of this plus the pressure of this plus the pressure of this that should equal the total pressure. Here they are. Pressure, pressure, pressure. So the total pressure is 1. Oh, I'm sorry. These are not pressures. These are mole fractions. So it's this plus this equals 1. So it's 75%, 22%, and 3%. 75% nitrogen, 22% oxygen, and 3% argon. So what is the pressure of the nitrogen? If the total pressure is 0.95 atmospheres, here, let me show you. This is quite easy. You don't have to know necessarily any chemistry about this, although the law of partial pressures is useful. Let's see. So we know that the nitrogen is at 75%, right? So 0.75 of all of the pressure is nitrogen. So if the total pressure is 0.95 atmospheres, see, 75% of means times 0.95 atmospheres equals, it's almost the same, it's almost 0.75. 0.75 times 0.95 is 0.71. So that's 0.71 atmospheres. That's the answer for the nitrogen. Okay? All right. That's how you do it. Bonus question. The definition for diffusion. Now, I was expecting you to remember this from some biology course that you've taken recently or some other science course. Some of you have taken some general science course offered by MSMU. But anyways, let me just tell you here right now. The definition for diffusion is the net motion. Here, I'll type it so you don't have to read my handwriting here. You don't have to have this definition word for word, as long as you have the general idea. Okay. This is a definition for diffusion. It is the motion, or the net motion. So make this a little bit bigger for you. It is the motion of particles from areas of higher concentration to areas of lower concentration, arising only from random Okay, so diffusion is the net motion of particles from areas of higher concentration to areas of lower concentration, arising only from random motion. I want you to understand what I mean by that, or what science in general, or maybe even what nature means by such a thing. Here, let me show you exactly what's going on with that. Suppose you have, yes, I know that diffusion is often discussed in science classes, but I think it's rarely sort of analyzed in terms of cause. So suppose you have a bunch of marbles in a box, a flat box, and you have all the marbles on this side, right? If you start to move these marbles by shaking the box back and forth, no tilting, just shaking. If you should happen to give these marbles some energy of motion, after a few seconds, you are going to end up with some marbles over here, right? So, let's see, you are, let's see, you you are going to end up with like this marble moved to. Oh, I can't move the marbles. Okay, so this marble is going to end up over here, and one of these marbles is going to end up over here. After you shake this box randomly, you are not going to have all the marbles crowded on the left side anymore. Why? Because there's extra space here. Just by the random motion of these marbles, some of them are going to end up over here. They're gonna spread out. It's just the random motion within available space. That's diffusion, right? There is nothing further involved here. Nature does not have a tendency to move particles from a higher concentration area to a lower concentration area. There is no such tendency. Uh, Diffusion happens only because of random motion. There is available space here. These guys are moving randomly. They are going to end up here just randomly, just because this space is available. There's nothing. There's no further trick involved. So, anyways, that's diffusion. The net motion of particles from a place where they're crowded to some place where they are not crowded, just by randomness. And that's it. Thank you, folks. Bye.